Section 1.6, solving quadratic equations. These are of the equation in the form ax squared plus bx plus c equals 0 for some value of x. Now, it might be there's no values of x that work, or 1 or 2. That depends upon something called the discriminant. Okay, so there are various methods of solution: by factoring, by square roots, by completing the square, and by the quadratic formula. Solution by factoring uses the zero factors rule. If a product equals 0, then one of the factors must be 0. For example, x minus 2 times x minus 3, x plus 3 equals 0. This means that either x minus 2 is 0 or x plus 3 is 0. This in turn means that x equals 2, and this means that x equals negative 3. So this quadratic has these two solutions: x equals 2, x equals negative 3. Here we have x squared minus 5x plus 6 equals 0. This needs to be factored for it to use this solution by factoring. Okay, to do that, we need to find p and q, whose sum is this middle coefficient negative 5, and whose product is this last term 6. A little bit of search will find negative 2 and negative 3 work fine. So this factors into x minus 2 times x minus 3 equals 0. So, okay, now we've solved by factoring. Either x minus 2 is 0 or x minus 3 is 0. So therefore, either x equals 2 or x equals 3, and these are the solutions to this equation. Here we have solve 2x squared plus 5x plus 3 equals 0. Now, okay, this requires, well, if you're going to solve by factoring, you need to use what's called the AC method. The problem is that there's a 2 instead of a 1 in front of the x squared. The AC method goes like this. You find two numbers p and q whose sum is the middle coefficient b, and whose product is a times c. Now, okay, and you find this by searching through a list of factors of AC. Then, having done that, you write bx as px plus qx. So you get ax squared plus px plus qx plus c. This will factor by grouping. Now, let me continue a digression by explaining why the AC method works at all. Well, okay, first let's use it. So for 2x squared plus 5x plus 3, so find p and q whose sum is 5 and whose product is 3. Is 2 times 3 is 6. And 2 and 3 work. Their sum is 5, their product 6. So having done that, this equation, 2x squared plus 5x plus 3, will rewrite by writing this 5x as 3x plus 2x. 2x squared plus 3x plus 2x plus 3 equals 0. This factors by grouping. This is a common factor, x times 2x plus 3. And if we pull out a 1, it'll be 1 times 2x plus 3. All that equals 0. This can be factored a little further. Pull out a 2x plus 3, and it'll be times an x plus 1. X plus 1 times 2x plus 3 equals 6. Now, factoring solution. Either x plus 1 equals 0 or 2x plus 3 equals 0. Transpose the 1 here, transpose the 3 and the 2 here. You get that x equals negative 1 or x equals negative 3 halves. Now, okay, a digression. Why does the AC method work at all? If you have p and q equals b, and p times q equals ac, then q equals ac divided by p. And then ax squared plus bx plus c, right? That is ax squared plus bx plus qx plus c. Right, this q is ac over p, and that times x plus c. Now, a tricky part here. We'll write this c as cp divided by p. That way, these two terms have a common factor of c over p. And then these two terms have just a factor of x. So these two terms pull out an x times ax plus p. Pull out c over p. We're left with ax plus p again. These factor out, ax plus p times x plus c over p. Well, so it works. It works in general. I know that's solution by AC method and factoring in general. Let me see down here. Do we have some examples? Pardon me. Okay, well, that'll do for now. Then there's solution by square roots. If you have the equation x squared equals c, you can write that as x squared minus c equals 0. The c is a root c squared if c is positive. So x squared minus root c squared equals 0. So a difference of squares factors into a difference times a sum. X minus root c times x plus root c equals 0. So either x minus root c is 0, so x equals root c, or x plus root c is 0, so x equals minus root c. We can rewrite, you can write this as x equals plus or minus root c. This symbol means plus or minus. It really means two numbers. So for example, x squared equals 49 means x is plus or minus root 49, so x equals 7 or negative 7. 2x squared equals 100. Well, we have to get rid of that 2. So divide both sides by 2 and get x squared equals 50. So x equals plus or minus root 50. And then with a bit of square root arithmetic, 50 is 25 times 2. So x equals plus or minus root 25 root 2. Root 25 is 5, so x equals plus or minus 5 root 2, and these are the two solutions to this. 3 times x minus 2 squared equals 36. Well, okay, first we divide by 3, so x minus 2 squared equals 12. Then take square roots. X minus 2 is plus or minus root 12. Transpose the 2, x equals 2 plus or minus, well, root 12 is root 4 root 3. Root 4 is 2, so x equals 2 plus or minus 2 root 3. And these are the two solutions to this. All right. Right after solution by square roots is the completing the square. Given you have x squared plus bx, we want to know what term here to make this a completed square. The trick is to divide this b by 2, b over 2. Square that, that's b squared over 4. Replace that b squared over 4 here, and this b over 2 here. For example, x squared plus 6x plus what equals what? Well, take half of 6, that's 3. Square that, that's 9. So x squared plus 6x plus 9 equals x plus this 3 squared. Or here, x squared plus y squared plus 9y plus what equals what? Take half of 7, that's 7 halves. Square that, that's 49 over 4. Place the 49 over 4 here, the 7 halves here. So y squared plus 7y plus 49 fourths equals the square of y plus 7 halves. So you can use completing the square plus solution by square roots to solve quadratics. Here's x squared minus 12x plus 1 equals 0. First, move the 1 over to the other side. So now we can complete the square. Half of negative 12 is negative 6. Squared is 36, add to both sides. Y squared minus 12y plus 36 equals negative 1 plus 36. This left side is x minus 6 all squared, like that. Negative 1 plus 35, 46 is 35. Now we have a square equals 35, take square roots. X minus 6 equals plus or minus root 35. So x is 6 plus or minus root 35. These are the two solutions to this. Here we have a 12x squared minus 5x minus 3. Well, we need to get rid of this 12 for completing the square to work. So we divide through it by 12. You get t squared minus 5/12 t minus a quarter equals 0. Transpose the 1/4. T squared minus 5/12 t equals 1/4. Now to complete the square, we take half of negative 5/12, so that's negative 5/24. Square that, that's 25 over 576. Add to both sides. T squared minus 5/12 t plus 25 over 5/12 equals a quarter plus 25 over 576. The left side will be t minus 5/24 squared, like this. This right side, I do a calculator. The scientific calculator will actually do integer fractions, fraction arithmetic, and this comes out to 169 over 576. All right, now we solve by square roots. Take square roots. T minus 5/24 equals plus or minus 169 over 576. Transpose of 5/24. 5/24 plus or minus, so this turns out to be 13/24. So 5/24 plus or minus 13/24. With a plus, you'll get 3/4. With a minus, you get minus 1/3. Here's t squared plus 23 plus 25 equals 0. Transpose the 25. T squared plus 20t equals negative 25. Then complete the square. Take half of this, 20, you get 10. Square that is 100. Add to both sides. So t squared plus 20t plus 100 equals 100 minus 25 is 75. This left side is a square of t plus 10, like that. T plus 10 squared equals 75. So t plus 10 equals plus or minus root 75. Transpose the 10. T equals negative 10 plus or minus, and removing a square, you get 5 root 3. So negative 10 plus or minus 5 root 3. Here we have x squared plus 8x plus 6 is 0. Transpose the 6. X squared plus 8x equals negative 6. To complete the square, take half of 8, that's 4. Square that, that's 16. Add to both sides. X squared plus 8x plus 16 equals 16 minus 6. The left side is x plus this 4, all squared, like that. 16 minus 6 is 10. At this point, it's pretty much routine. Take square roots. X plus 4 equals plus or minus root 10. So x is negative 4 plus or minus root 10. Solves this. Now, we'll use completing the square and solution by square roots to make a general solution, a quadratic formula. So starting with a general formula, ax squared plus bx plus c equals 0. First, we'll divide by a to get rid of it in front of the x squared. X squared plus b over a plus c over a equals, well, 0, a is 0. Transpose the c over a. X squared plus b over ax equals negative c over a. Okay, now we complete the square. Half of b over a is b over 2a. Square that, b squared over 4a squared. Add to both sides. So x squared plus b over a, x plus b squared over 4a squared equals b squared over 4a squared minus c over a. This left side is a square of b plus over 2a, x plus b over 2a, like that. This, after a very small amount of algebra, is b squared minus 4ac over 4a squared. So, okay, solution by square happens. Take square roots. X plus b over 2a equals plus or minus root b squared minus 4ac over root 4a squared. Okay, this root 4a squared simplifies the 2a. Transpose the b over 2a, so x equals minus b over 2a plus or minus root of b squared minus 4ac all over 2a. Put that over a common denominator to make it a little more compact, and you get the solution. X equals negative b plus or minus root of b squared minus 4ac all divided by 2a. And that is the quadratic formula. So for example, 2x squared plus x minus 3 equals 0. A is 2, b is 1, c is negative 3. Plug it in, b is 1 here and here. A is 2 here and here. C is 3 here. Okay, so that reduces to negative 1 plus or minus root 25 over 4. Root 25 is 5, so x is negative 1 plus or minus 5 over 4. With a negative 5, it reduces to negative 3 halves. With a positive 5, it reduces to 1. X is negative 3 halves, or 1, solves this. 12x squared, t squared minus 5t minus 2 equals 0. Here let a equals 12, b equals a negative 5, make sure that the sign is there. C is a negative 2, make sure that sign is there. So x equals minus b negative 5 plus or minus root of b squared negative 5 squared minus 4 times a, 12, times c, negative 2, all over twice a, twice 12. Okay, that's 5 plus or minus root 121 over 24. That's 5 plus or minus 11 over 24, which is negative a quarter or 2/3. Okay. Now I mentioned that there may be no solution, one solution, or two solutions to the equation. It all depends on this part here, b squared minus 4ac. That's inside a square root, and therefore makes sense, at least in the real numbers, only if this b squared minus 4ac is at least 0. There are no real square roots of negative. If this was 0, square root of 0 is 0, 1 value. And if this is positive, you have plus or minus a positive number, 2 possibilities. So, just a second, someone just came in. Right. So, this b squared minus 4ac is called the discriminant. If it's positive, there are 2 real roots. The graph y equals ax squared plus bx plus c crosses the x-axis at 2 places. If b squared minus 4ac equals 0, then the graph touches the x-axis at 1 spot only, 1 root, often called a double root. And if b squared minus 4ac is negative, then the parabola misses the line entirely, So there are no real roots. There are two what are called complex roots that involve the square root of -1, a new kind of number. All right. If b squared minus 4ac is a square of a ratio of a whole number, then you get rational roots. If it's not a square of a whole number, then you get irrational roots. So, for example, as for what kind of roots for these equations? 4x squared minus 4x plus c. The discriminant is b squared negative 4 squared minus 4 times 4 times 1, 0. So you get a single repeated root. 5x squared plus x plus 2, 1 squared minus 4 times 5 times 2 is negative 39. So there'll be this means that there'll be complex roots. Since this is not a square of a whole number, there'll be two irrational complex roots. Here you have x times 2x minus 3 equals 20. After a bit of algebra, that's 2x squared minus 3x minus 20 equals 0. Discriminant is minus 3 squared plus 4 times 2 times negative 20, which is 169 or 13 squared. There's two rational real roots. Then here's 3x squared minus 10 equals 0. The discriminant is, well, b is 0, so that's a 0 squared, minus 4 times 3, that's a, times negative 10, that's c. Comes out to 120, a positive number, so there'll be real roots, not a square of an integer, so it'll be two irrational real roots.